A cage holds some chickens and some rabbits. You can count 10 heads and 26 legs. How many are chickens and how many are rabbits? Two different animals, two unknowns. It feels like it wants algebra. Two equations with two letters, a bit of a headache. And if you panic, you might just divide 26 by something and hope. But you can settle the whole thing calmly, with a simple drawing and some counting you can see. The plan is simple. Draw the easiest possible version, the one you can picture at once. Measure how far it falls short. Then fix the drawing by the amount each swap changes it. No algebra anywhere. Start with the simplest picture you can. Pretend, just for a moment, that every single animal is a chicken. Draw all 10 heads in a row and give each one 2 legs, because a chicken has 2. 10 little 2-legged bodies and not a rabbit in sight yet. Now count the legs you actually drew. 10 animals, 2 legs each, 20 legs in total. But the real cage has 26 legs in it. So your all-chicken drawing is 6 legs short of the truth. And those 6 missing legs are not lost. They belong to animals you have drawn wrong. Here is the fix. A rabbit is just a chicken with 2 extra legs. So each time you turn a chicken into a rabbit, you add exactly 2 legs to the drawing. 6 missing legs, added 2 at a time, is 3 rabbits. So give 3 of the 10 their 2 extra legs each. Watch them turn from chickens into rabbits, and the picture now carries exactly 26 legs. 3 rabbits, and the other 7 simply stay as chickens. Check it against the real numbers. 3 rabbits at 4 legs is 12. 7 chickens at 2 legs is 14. 12 and 14 make 26, exactly the count in the cage. The drawing was right. You could just as well start the opposite way. Pretend all 10 are rabbits, 4 legs each, 40 legs. That is 14 too many now. Each chicken has 2 fewer legs, so 14 over 2 is 7 chickens. 7 chickens and 3 rabbits, the very same answer, reached from the opposite end of the problem. Either simple case works perfectly, as long as you measure the gap honestly and fix it by the per-animal difference of 2 legs. Pick whichever start feels easier. So when a problem has 2 kinds of things mixed together, do not reach for algebra. Draw the simplest case, where everything is the same kind. That drawing is easy, and it will be wrong by a clear, countable amount. Then measure that gap, and close it by converting items one type into the other, each single swap worth a fixed, known change. Divide the gap by that change, and you know how many to convert. The picture does the thinking for you, and the answer just appears at the end. Your turn. There are 6 bikes and tricycles together, with 16 wheels in all. How many are tricycles? Draw all bikes first, then fix. Pause and try. All bikes would give 12 wheels, 4 short of 16. A tricycle has just 1 extra wheel, so 4 missing wheels make 4 tricycles, leaving 2 bikes. Check, 4 3s and 2 2s is 16. One more. 8 creatures, spiders with 8 legs and beetles with 6. 54 legs altogether. How many spiders? Draw the simple case, the one with fewer legs each, then fix it, pause and try. Pretend all 8 are beetles, 6 legs each, which is 48 legs, 6 short of 54. A spider has 2 more legs than a beetle, so each swap adds 2, and 6 over 2 is 3 spiders, leaving 5 beetles. Check it, 3 8s and 5 6s is 24 and 30, exactly 54. This picture trick cracks a whole family of puzzles. Legs and wheels, coins of 2 values, right and wrong answers. Anytime 2 kinds of thing are mixed and you know a total, assume all one kind, then convert to close the gap. A drawing you can actually count beats a formula you cannot quite remember. So when 2 things are tangled together, draw the simplest case, count how far it falls short, and convert one type into the other to close the gap. The picture turns a puzzle into plain counting. That's all for this video.